The number of coffees sold in a day at an airport coffee shop is related to the number of flights delayed out of the airport on that day. The table shows data on the number of delays and the number of coffees sold for 10 days. Complete the statements describing the situation. First of all, we need to use Desmos on this, and the Edmentum tutorial uses that. And I have practiced, so I hope that I can do this on the iPad. It is not going to be a short video, starting with putting in the 10 pieces of data into Desmos. And I have it written down. I have the data written down. So as I reset my Desmos, I'm going to go to plus, and then the table, and then we're going to type in the data. So 54, 132, 62, 129, 66, 139, 70, 141, 75, 152, 77, 145, 79, 155, 84, 151, 87, 162, and 89, 163. So once we get that data put in there, let's hit the minus sign over here until we can see the data. There we go. I'm going to spread that out a little bit. When we go back and look at Edmentum, it says the data set is best modeled by a quadratic or a linear. Well, a quadratic would be a U-shaped curve, and we don't have a U-shaped curve. It seems that our data is kind of grouped together linearly. And if we take and look at this, what's happening as we come from the left, our graph is going upward, which is going to allow us to answer that next question. By the way, the data is best modeled by a linear with a positive slope. So now what it says based on the model, if there are between 90 and 100 delayed flights, the coffee shop should be prepared to sell between those amounts of coffee. So we've got to figure that out. But before we do, we're going to go back to Desmos, and on the next line, what we're going to type in is we're going to type in the equation of slope-intercept, which is y equals mx plus b. And I'll have to switch over to my paper here in a minute. But when you type this in, we're going to type in y1, and then I'm going to go to ABC, because we have to type in this symbol right here. You can just see the bottom of my finger. That to me is approximately. And then we're going to type in mx1 plus b. So I'm using my ABC button again to get that all in there. And now what we have is we have some information down here about our equation. And what it did is it drew this black line on my iPad, which is the line of best fit. So what I'm going to do is I'm going to flip over to my paper here, and I'm taking down this information. At the very bottom of this second box it says parameters. M equals 0.970662, B equals 74.7798. And so what I did is I have that written down in the format of y equals mx plus b, And without bringing my iPad back over, I do need to go back and look at Edmentum, but it says, based on this model, if there are between 90 and 100 delayed flights, then the coffee shop should be prepared to sell between. Well, what we're going to do is we're going to take this 90 and we're going to put it back into the equation. So I am going to have to flip back over to Desmos one more time. But we're going to put 90 in here, and maybe just doing one will be enough so we don't have to do both. But we're putting 90 back in for the x. And that is because x are the flight delays. So we come back over here, this line. I didn't even really need to write it down again, I don't think. But if we write down 0.97 times 90 plus 74.8, we get 162. Again, I'm going to go back and look at the answers there, but that might be enough to tell us between 162 and, let's just check it because this is the first one that we've done. But if we go back to Desmos, if we put in 100.97 times 100 plus 74.8, we get 171.8, which rounds to be 172. So between 162 and 172 copies.